So we want to set up a local React project. With local, I mean we don't use CodePen, but instead we will have a project on our machine where we can work in with our own IDE or editor. This, of course, is the way we want to work with React. We want to have it on our machine. We have more features available there. It's more convenient than using some web editor. And CodePen, which we used before, or JSBin, which we used in the optional second module, are really more playgrounds than real work environments for real projects. So we will set up a local project, and React is actually more than just importing the two files we imported in CodePen. We need a more elaborate workflow for real projects, and this is recommended for both single-page and multi-page applications. The question, of course, is why do we need a more complex workflow, and how do we then achieve it? Let me start with the why. When building a real app, we want to actually optimize our code. We didn't care about this in the demo project in the first course module on CodePen, but for a big React application, we want to ship code that is as small as possible and as optimized as possible, obviously, because that increases the performance of our app. Additionally, and that is super important, we want to use these next generation JavaScript features I taught you about in the last optional module. Now, we want to use that because it makes our life as a developer much easier. And it's the de facto standard for React apps to use all these next-gen features, because the code is leaner, easier to read, faster, less error-prone, and many other reasons. So you should really use these features. It's not just something nice, optional. I strongly recommend using these features. It is considered a best practice, and it is what I teach you in this course, because obviously I want to teach you best practices. So we want to use next generation JavaScript features to have an easier time to write less error-prone code. And with all that, we need a workflow that supports these features. Even on CodePen, we implicitly did this. Remember that preprocessor dropdown where we switched to Babel? That behind the scenes unlocked a couple of build tools that would parse our code and support JSX, this HTML and JavaScript syntax, for example. So we want to use these next-gen features. Essentially, we want to be able to write ES6 or above code and still ship code in the end that runs on as many browsers as possible. And not that many browsers support all these next-gen features. That is why we need a build workflow that actually compiles these features. Finally, in the end, we want to be more productive. This includes next-generation JavaScript features, which often allow us to write more condensed code. But it also includes things like CSS auto prefixing. You might know that CSS prefixes are a thing to achieve the broadest possible browser support for CSS features. Now, manually adding these prefixes is quite annoying, so automatically adding them is nice. Or consider linting, so a tool which actually warns you if you are writing suboptimal code. That would be nice to have too. Not strictly required, but a nice feature. And all these things should be part of a build workflow. Now, to implement them there, we need a couple of tools that actually let them run over our code, to either warn us in the case of linting, or to compile the code to code that runs on as many browsers as possible, whilst we, as a developer, are writing very modern code that would, on its own, not run on that many browsers. So that's the why. A couple of reasons why writing this kind of code is desirable and why we need a more complex build workflow that actually allows us to write this code, that actually optimizes the code for us. And for that, the how, of course, is relevant. How do we achieve such a workflow? We first of all need a dependency management tool. Dependencies are simply third-party libraries, third-party JavaScript packages. React, for example, is a dependency. React DOM is a dependency. And also all the build tools we will need in the end are dependencies. So the compiler for next-gen JavaScript to current-gen JavaScript, that is a dependency. And we will use NPM here. Yarn would be another tool you could use, but we will use NPM, Nodes Package Manager, a tool which just allows us to manage packages and which is the de facto standard for managing dependencies also on front-end projects. Besides that dependency management tool, we need a bundler because we want to Write modular code and split it up over multiple files so that each file has a clear task, a clear focus, and therefore is easier for us to maintain and manage. But then we want to make sure that all this code gets bundled into a couple of files in the end when we ship it. Because browsers don't even support split up files, older browsers at least don't do. And it might also, even if they did support it, not be that optimal to make thousands of requests to all these tiny focused files. So we want to have that bundler, and we will use Webpack, which is the de facto standard for bundling these days. The cool thing about Webpack is it doesn't just bundle files, it also allows us to apply a couple of other build steps before it does this bundling. For example, the mentioned compilation of next-gen JavaScript. That requires another tool, Babel. We need a compiler that does this JavaScript compilation, which means translation from modern features to workarounds that also work on older browsers. And we will use Babel plus presets, which can be hooked into the Webpack configuration so that they are part of this bundling and optimization process. And finally, in the end, we want to use a development server to test our app locally on our machine. Development server is a web server, but one running on our machine. We could open a HTML file by double-clicking on it, but this would use the file protocol and would not correctly emulate the app running as it runs on a web server. So we need a web server, and we can of course run one on our local machine. This server is then only accessible by us, but that's all we need as a developer. And there we can really see the app run as it will run in the end on a real server. We need all these things, and it sounds like that's super complex to set up. The good thing is it's not. I will present you a tool that will create a project supporting all these things out of the box with zero configuration in the next lectures. We will install this tool together, and it is a tool created by the React team and community and the officially recommended way of creating new React apps. Because that's the general theme of this course, I will teach you things in the best practice and recommended way. So all of the setup is quite easy. And as a side note, if you still want to dive into how this works behind the scenes and you want to set this up from scratch, I also got a module for that towards the end of the course, where we will build a React app, a React project from scratch. Now with that, you know what we need and how. Now let's dive into that tool I mentioned and let's learn how we actually get started with a new React project supporting all these features.